Okay, good morning. Welcome to the second week of the shutdown. Uh, we're going to start the concept of polymorphism today. Now, I have already given you a brief idea about what polymorphism is. Now, what we are going to do today is try and understand why do we need polymorphism. Now, I'm going to explain the concept of polymorphism, why polymorphism is so important, why is it so powerful for a programming language. So I'm going to deviate a little bit away from a normal presentation or my normal PPT, which I would be probably sharing with you. And I'm adding this extra bit here so that you can understand the concept of polymorphism in the true sense. I'm going to relate the entire concept of polymorphism using a simple example, right? And then we will get back to our main sessions wherein we learn how to do the polymorphism through C++. So let's start. The first question is, why do we need polymorphism? Okay, now if I come to your class and say, guess what? I saw an animal cross the road. Now this question is for you to think. This statement is for you to think. If I said, guess what? I saw an animal cross the road. What would your reaction be? What would you think? Can you all think about an animal? Can you all think about like how an animal actually looks like? Now, probably you would ask another question back to me. Sir, can you be more specific? Because what you are telling us is a very generic statement. How does an animal look like? Well, all of us here have different picture of an animal. So, what I intended to put across to you was that we cannot exactly think about how an animal looks like. Well, we can think about a dog, we can think about a cat, we can think about an elephant or a cow or a monkey, but an animal object, difficult. So I really don't know what you're going to think. So someone could have probably thought about that an animal looks like a cow, or it could be like anything. It could be, different kinds of animals. So all of these are animal objects. Now, it's very difficult for us to visualize one of them as animal because all the animals which are here are animals in fact. So what do we do? So there is a problem. So if I create a class called as animal, that class is going to be a generic class because you asked me a question. So be more specific. An animal is a very generic thing that you're saying. So exactly what can we do with an animal class? Now, can we have a class called as animal? Yes, we can. We can have a class called as animal. Now, what can we do in that class? Now, what we can do is we can take a look at all these animals here, right? And we can extract all the common properties that these animals have and we put them into that class. So an animal class can be a perfect superclass or a base class having the common properties of all the animals around here. Does that make sense? Absolutely. Now, tell me one thing. Do you think it would be wise for us to make an object of the animal class? Not quite. Because since the animal has only the common properties which are across all these animals which are shown on the screen, it has no specific properties. So if you make an object of the animal class, that object is going to be a weird object. You would have I would say it would be more like a handicapped object which is not complete in a nature. I can say a dog is a complete object. I can say a cat is a complete object, but animal, no, it's not complete. It's just we are taking the common properties of all the animals and I'm putting it into an animal class. So if I create an object of the animal class, it's kind of weird. How will that object behave? What are going to be the attributes of that object? Because we can't visualize an animal by itself. So the properties of an object or the behavior of an object is going to be abstract. Right? And that's the reason later on when we go ahead all the superclasses which are generic in nature should be made abstract. So what exactly is the property of an abstract class? So if you make a class abstract, one of the properties is that you should not be creating any instance of a class, which means that you should not have any objects of an abstract class. Now that's the understanding of what abstract class is and why a superclass is generic in nature. Okay, now let's move to an animal class. Now, one common behavior that is applicable to all the animals that you saw in the picture previous to this slide was that all the animals make sound. Am I correct? Yes. So I can associate one common behavior, sound, right, with an animal class. Now, a tiger can be an animal, and it would be a perfect fit into the relationship of inheritance, because if you try out the is a relationship, tiger is an animal, yes. Similarly, a monkey is an animal, yes, and a cow is an animal. So all the three classes here would be the subclasses of the animal superclass. I think that's pretty clear amongst all of you, because we've done this in inheritance as well. Now consider that we have a sound function which is common to all the three, and the fact that these are common to all the three, I have put them into an animal class, right? Now what's the problem? The problem is, if I have the sound function in the animal class, I'll be writing some code for it. So what code are we going to write? What is the common sound that all the animals make? Well, there are no common sounds, because a tiger has its own sound, a monkey has its own sound, and a cow has its own sound, right? So if we have a common sound function in the animal class, then all the three animals, or in fact all the animals or the subclasses which derive from the animal class, will be making the same sound. So you would have a monkey. So if you implement the barking sound in the animal sound function, the tiger, the monkey, the cow, the cat, the tortoise, the snake, everyone would be barking. Well, not right, not correct. So what do we do then? We don't use the sound class at all. That means we don't write anything in the sound, because all the animals have very specific sounds. So we need to write an implementation of the sound in each of their classes. So a tiger should have a sound class where the sound that the tiger makes should be implemented. Similarly, the monkey would have its own class where there would be a function called the sound, and the implementation of its own sound should be put there. Similarly, a cow and a dog and all the other subclasses which are actually going to inherit from the animal class. So that is how it should be. And now this sound should have no implementation at all. It should be blank, and all the implementation should be in the specific classes, the functions of the specific classes, right? Now, how do you access the sound for a tiger? So if I have to access a sound for a tiger, I need a remote control, or I need a reference of the tiger object. So each of these objects would have to be controlled by a remote control. And what exactly is this remote control? Remote control is basically the way by which we can invoke a function. So think of this remote control as a function call. Every button on this remote control indicates the function which is associated with that object, right? So if I create a reference or a pointer variable of this class, so if I have a PTR for tiger, and if I have another PTR for monkey and another PTR for sound, which I'm talking about PTR means I'm talking about a pointer reference, a pointer variable, which is referring to this objects here, then by pressing the button I can invoke the sound for all the three objects. So what is the implementation of this? So if I need to invoke the sound of a tiger, I need to use a remote control which is specifically made for a tiger. If I need to invoke a sound for a monkey, then I need a remote control specifically for a monkey. if I need to invoke the sound for a cow, I need a remote control specifically for a cow. Alright, so what is the big problem here? Well, the big problem is that every time you create an object of the subclass, you will have to create a separate remote control. Right? Now, what's the big problem again? Well, just imagine you're sitting to watch a TV, right? And you want to watch a cricket match, and then you want to connect it to the home theater. You have your AC, you have your setup box, and you have all your electronic equipments. And now each of these electronic equipment has their own remote control. Now if you want to watch a cricket match, you want to adjust your AC settings, you want to adjust the setup box volume, you want to adjust the TV volume, you want to adjust the home theater settings. So for each one of them you have your remote control. Now imagine sitting down to watch a cricket match with around 4 or 5 remote controls. Wouldn't that be a little bit complicated and tricky? What would we actually prefer to have? We would want, a life would become simpler if you can just have one remote control to control all these equipments. Now can that happen? Well, that is magic. So with one remote control, if I can control all the equipments, then that's magic, and that's what I want to do. And that exactly is polymorphism in the real sense. So rather than making remote controls for each of these objects here, subclass objects, if you can have one remote control through which I can control all the subclass objects, that is what I want to do, and that is the magic of polymorphism. So in C++ or in any programming language, how do I achieve that? Right? So that's what we're going to see. Now another question which should have crept in your mind is that if we are going to have a separate sound functionality or a body for each of the subclasses that you see on the slide here, what is the need of a sound function in the animal class? Because the sound function in the animal class is not going to have any code, right? So what is the reason why we need to have a sound function there? We can just remove the sound function from the animal class, keep it all there in the lower subclasses, and then fine, with every remote control these sounds are going to be operated. But as I told you, that having remote control for each of these objects is going to be complex, and the magic of polymorphism is that control everything using one remote. So we are looking for a universal remote, a single remote by which you can operate all the 3 different objects of 3 different classes. Okay, so just to summarize once again, what are the problems? The problems are, with this architecture, with this solution, we have too many remotes. For every subclass object, a remote control is required, which basically leads to a complicated code. So what exactly is the solution for this? So the solution for this is to create a single remote which can operate on all the objects of the subclass. Now, before we actually talk about that single remote, tell me, do you think we can create a single remote of the cow class? Well, yes, we can. However, imagine with that cow remote, you would be controlling the monkey object and you would be controlling the tiger object. Well, they would not be very happy because there would be a cow remote controlling a monkey and a tiger. Similarly, when you create a remote for a tiger and you try to control a monkey or a cow, again, it's not a very happy situation. They would not love to. However, can you give me a name of a class? If we create a remote of that class, then all the subclass, the tiger, the monkey, and the cow would be happy. Well, yes, you got it right. So if we create a remote of the animal class, all of them would be happy because all of them are animals. They belong to the same group. So a universal remote or a single remote that is created in polymorphism is always created from the base class. Did you get that? All right. So we have to create a single remote of the animal class. Now, if you want to put a button on that remote, you need to specify what button it is. For that exact reason, we have to have a sound function in the animal class. Although the body of the sound function is not going to be used, but just to make a button on that remote control, because we are making the remote control of the animal class, the sound function has to be defined in the base class. So the question is, why do we need a sound function in the base class when we are anyway writing it in the derived classes for each of the objects or the classes? Is this, the answer is this: to create a button on the universal remote control, which is going to be the remote control of the animal class. That button indicates the sound function. Although this sound function is not going to be used, but the button needs to be there on the remote. So I hope this is clear. If you have a doubt, you can always ask me when we have the Zoom class. So what is our objective? The objective is to have a single remote. And this single remote would work with a tiger object, would work with a monkey object, and would work with a cow object. So how should it work? So when this remote would point to a tiger object and you press the sound button on it or make a function call of the sound, then the tiger sound function should get invoked. Similarly, when you point to the monkey and press the same sound button, this time the sound of the monkey object should be triggered. Similarly, if you point to the cow and press the same sound button, the cow's sound method or the function should get triggered. Now, if we can achieve this, that's what polymorphism is all about. So just let's look at this from the code perspective. Like, how do you create a remote control? When I'm saying a remote control, what exactly do I mean? So let's look at it from a C++ code perspective. So if you look at, there is an inheritance here. Animal is the superclass, dog is the subclass. So I'm creating a remote control here. So what is a remote control? It's nothing but a pointer variable of the type animal, right? Now, an important property that we have discussed in the last class was, if you create a pointer variable of your base class, using that pointer variable, you can point to the objects of the derived class. You remember that, right? Now, that is where that property of, the base class pointer variable is going to help us achieve this polymorphism. That property is basically going to help us create this universal remote. So if you look at this code, you have animal star PTR. So PTR is nothing but my animal class, right? Now what am I doing here is, using this animal class PTR, that is the remote, I am pointing to a new dog object. So I'm creating a new dog object, which is basically the object of the subclass, and PTR is pointing to that dog object. And then I'm invoking a function PTR sound. Now in this case, what will happen is, if you've seen the previous example in the last class that we discussed, that always the base class pointer, the function which is associated with the base class pointer, will get invoked. So in this example, the sound of the animal class will get invoked. But our objective is to invoke the sound of the dog class. So using this example, if I can invoke the sound of the dog class, I have achieved polymorphism. So what is the overall objective of doing polymorphism? create a remote control of the base class. Using that remote control of the base class, point to any derived class objects, and when you invoke a function in the derived class objects, it should always invoke the derived class function, not the base class function. How do we do it? That's going to be a part of another video. So this video is a concept video which explains to you the power of polymorphism. It also explains to you why we must do this polymorphism, what is its usefulness, and how it can help in writing simpler code, and how it can bring about that power of controlling everything with just one pointer or a reference variable, or you can also call it as a remote control, right? So to make a life simple, control all the equipments in your house with just one universal remote. How that universal remote is created, it's a magic of polymorphism. So if you've not understood this video, please go back and listen to whatever I've said very carefully, and I will see you again, and we'll continue with all the next technical stuff that is associated with polymorphism in our normal slides. So watch this video carefully, because understanding the concept of polymorphism is important, and come back soon for the next video, which I will continue with the normal classes. So have a good day and keep studying well. Bye.